In this third video from Module 14, we consider extrusive volcanic processes. So before we get into extrusive volcanic processes, it's helpful to sort of remember the two types of volcanism, and we've talked about these a little bit in a prior video. So we have the extrusive one where molten magma is emerging from the Earth's surface, forming into lava or hardening into lava, as in this example. And then the other type of volcanism, which we'll talk about in a subsequent video, called intrusive volcanism. And that's where magma hardens underground and is later exposed through erosion. So here we have Half Dome in Yosemite Valley, California, that was essentially a pool of magma that hardened underground and was later exposed through erosion. Well, when we talk about extrusive igneous processes, it's useful to consider what happened to the sleepy Roman city of Pompeii in AD 79. So we see here in the distance Mount Vesuvius, and Mount Vesuvius is located about the center top of this slide. And this map is in Italian, but you can tell what's going on. Naples is over here on the sort of upper left-hand corner, and then we see Pompeii here just a little bit to the southeast of Mount Vesuvius. Well, everyone knew that Mount Vesuvius was likely to show some signs of eruption, but no one could have predicted that it would erupt the way it did in AD 79. And what happened was enormous amounts of volcanic material was ejected from Mount Vesuvius, which began to fall on the sleepy town of Pompeii. The story from the time is that, or I guess you say the story that archaeologists tell us now is it was probably the heat that killed a lot of people. Probably the ash came down and didn't help things, but it was really the tremendous heat that probably killed people. And these are people who probably stuck around a little bit too long in Pompeii and were killed. And some of them we can find plaster casts even of how they perished. And if you go to Mount Vesuvius and to the museums at Pompeii today, you can see these plaster casts. These are the places where there were sort of openings that were left behind by the bodies that were encased in ash. And this is Pompeii today. You can tour the streets and a view of Mount Vesuvius with the rim of the volcano. You can actually walk around the rim of the volcano today. You can see there's a visitor center on one edge of the volcano. So, okay, a little bit about extrusive volcanism, some features that go with extrusive volcanism. Of course, we have lava, which is the liquid form of rock, and this is lava flowing. It can be somewhat viscous and it can flow pretty easily, especially if it's hot. And we have just here a comparison of two kinds of lava that are found in Hawaii volcanoes, the Hawaii Volcanoes National Park area on the Big Island of Hawaii. I'll be talking quite a bit about Hawaii volcanoes, but we've got this, the upper example here is lava that tends to flow more like and kind of ooze a little bit. It's more liquidy, and the bottom kind is a drier kind of lava, and they just form at different times. Here's an example of that, the chunky stuff flowing over the more ropey, smoother type of lava. So sometimes you find just different eruptions associated with different viscosities, if you will, of lava. So one question that people have about the Hawaiian Islands is, we've talked a little bit about it, how you have these volcanoes and also earthquakes along plate boundaries. So what's going on with Hawaii? How come Hawaii has volcanoes if it's not located along a plate boundary? I mean, it makes sense that you'd find a volcano out in the middle of the Atlantic Ocean along the mid-ocean ridge, but not so much that you'd find Hawaii right here in the middle, just above the letter F in Pacific. That's the location of Hawaii. So why here? Well, it has to do with the plate moving over a hot spot. So the hot spot is shown right here by this plume of red, and that would be where molten rock or magma is coming up. And a volcano forms at the same time that the plate is moving. So imagine this plate is moving sort of from right to left here, forming these different islands. And that's why if you look at the Hawaiian chain, you see progressively older volcanoes are away from where the plume is. And we can look at that here in this next series of images. So one of the older islands, the island of Kauai, the Garden Island shown here 3 to 4 million years ago. And as you get a little bit farther to the southeast, you find the newer islands. So as we get closer to the big island of Hawaii, there it is, we see that the big island is, its age averages around 0.2 to 0.7 million years ago. And there's actually new material forming over on this southeastern side of the island, even as we speak, and an undersea volcano here in this area to the southeast forming as well. So I'll put that undersea volcano in red so you can see it. But imagine the whole plate as it moves across this hotspot allows for the formation of new islands over time. Kilauea lava lakes like this one exist. If you go to Hawaii Volcanoes National Park, I strongly encourage you to go check it out. It's pretty amazing. You also see places where the lava comes in contact with vegetation and creates methane gas, not something you really want to breathe. And this is where the lava is entering the ocean, comes in contact with the ocean, kind of makes a lava delta, if you will, new land. So this is brand new land that's being created in the United States as the island of Hawaii gets a little bit bigger. Okay, a little bit about Hawaii lava flows in humans. It's not such a good thing if a lava flow comes to your neighborhood, and they do in some parts of the Big Island, and there's not much you can do to stop them. I mean, you could try to slow them down, you could build a wall, or you could try to spray them with water, but there's probably not much you can do if they have a mind to invade your space. And this is the Royal Garden subdivision on the Big Island, Hawaii, and I'll show you a map here in a second so you can see and appreciate how big this area is. The Royal Garden is in this area right here where I'm pointing, Kilauea Volcano, and this area right here, Royal Garden. And Hilo, Hawaii, sort of the capital of and also the place where most flights come into Hilo, or also the Kona Airport on the other side of the island. Just for perspective, and the Mauna Loa is the biggest part of the island. It's not the highest location on the island. That's actually Mauna Kea, but Mauna Loa is really the whole thing sort of makes up the Big Island of Hawaii. And this is a view you can see. This region right here I'm circling is the area where new land is being added, where and that Hawaiian, or I should say Royal Gardens subdivision is located. And here's some of the areas around Royal Gardens that have been affected, or Royal Garden, by lava flows that have happened over various time periods. And this slide's a little bit on the old side, but here's an abandoned home in the Royal Garden subdivision, and there are roadways that are completely covered with lava that's hardened, long since hardened, and are blocked. And so it's not too easy to get around in some parts of this area of the island. Some of this is just you can really only get to it by walking. Okay, a little bit about some types of volcanoes. I kind of want to draw a distinction between 3 types of volcanoes: active, dormant, and extinct. So what is an active volcano? Well, it's a volcano that's showing some activity, like ash is coming out of it, or steam, or perhaps the volcano is erupting. A dormant volcano is one that has erupted within recorded history and has the potential to erupt again. So the plumbing is there for the volcano to erupt at some time in the future. A good example, Mount Lassen, part of the Cascade mountain range that comes into California, Northern California. So it certainly could erupt again. It has the potential to erupt, but it's not erupting right now. So we throw it in the dormant category. And then an extinct volcano like Broken Top here in Central Oregon, the plumbing is really gone. This is not going to erupt again. It's just the remnant of where a volcano once existed. Okay, a little bit about some eruption types. Some types of eruptions are pretty violent, and they're oftentimes associated with composite volcanoes and calderas. So a composite volcano is one that has this sort of buildup of material over time from eruptions that have taken place that may actually block and sort of block the main vent, I guess you'd say, of the volcano. They have these flanking eruptions like the one I'm pointing at right here on this top view. Composite volcanoes would include Mount St Helens. We'll look at some examples of Mount St Helens. It blew its top in 1980, where about a third of the volcano exploded and was literally blown off the top. Some other composite volcanoes you might be familiar with. Some include Mount Kilimanjaro, in Africa, and Mount Fuji in Japan. Also Mount Rainier in Washington State. It has Mount Rainier is on the Washington State license plate, or at least it used to be. So it's a pretty famous composite volcano. Caldera is where a volcano blows its top and then sort of collapses on itself, creating a giant crater. So that's usually, like I say, a composite volcano blowing its top and sort of collapsing on itself. And we'll look at some examples of how these things form in a second. The second example, cinder cones. These are much smaller. They're made out of tiny cinders instead of like flowing eruptions like you would with a composite volcano or one very violent eruption. And as in the case of Mount St Helens, here we have little cinders, just like the ones you buy if you buy the cinders for, let's say, a gas barbecue. You have a gas barbecue that you use for cooking your hamburgers and hot dogs. You can buy bags of cinders, and they come from cinder cones. So cinder cones are made up of these tiny little things that are ejected from volcanoes that rain down and form. And then the third type of volcano is probably the least dangerous, and it's the one that formed the Big Island of Hawaii, and that's the shield volcano, and that is associated with massive volcanic flows of lava. So shield volcanoes are not particularly dramatic to look at. They're sort of flattish looking, but they're quite large, and they involve the flows of liquid rock in the form of lava. Just to show you the location of some of the Earth's major volcanoes. Again, as I've mentioned previously, the volcanoes often are found along plate boundaries, not always, as in the case of Hawaii, but frequently along plate boundaries. And you see that Japan and Southeast Asia has a lot of volcanoes, the Philippines, and we have quite a few in the Cascades. The yellow dots are inactive volcanoes. The red dots are volcanic or active volcanoes. All right, a couple of features. Let's sort of walk through. We've already talked about lava, so we won't spend a lot of time with lava, but lava flows are pretty interesting. Here's a kind of a sort of an innovative way of heating your ravioli, if you're so inclined. But I thought I'd mention that you can see lava flows that have happened in the past in a lot of places. This is near Baker, California, in Southern California. This is a volcano here you're looking at, and you see this person right here standing on a massive lava flow that might be 10,000 years old, which is pretty young for lava flows. Geologically speaking, it's kind of young. Some other places that have been affected in a big way by lava flows, this area that sort of separates Washington, the states of Washington, Oregon, and sort of even crosses over into Idaho and even into the area that we know today as Yellowstone National Park in Wyoming. These are the Columbia River basalts and other flows that have covered hundreds of square miles of lava that's just flowed in all directions. So just imagine, they call them the flood basalts because they just flooded everywhere. They went into existing river valleys and just kind of covered everything on the landscape. And here's an example. This is a view from Oregon, but you see successive lava flows here. The youngest ones are the ones up on top, and then as you go down to older ones here down closer to the bottom of these valleys. But these are successive lava flows that have happened associated with the Columbia River basalts. Here's what some of these features look like. Sometimes the lava sort of pushes upward and forms what's called a splatter cone, where stuff is sort of going everywhere in every direction. These splatter cones, Craters in the Moon National Monument in southern Idaho has some amazing splatter cones that you really want to see if you get a chance. This photo is from Craters in the Moon, and this one you can actually walk up. This is an old one. This thing isn't erupting now, but it did about probably around 20,000 years ago. But this trail right here takes you up so you can kind of look inside. Here's another view of a splatter cone with another cone nearby. This one's active, and you can see that red color is flowing lava that's coming out of the splatter cone. All right, some other features. Volcanic peaks, I mentioned some famous composite volcanoes. Here's another one, Mount Shasta in California with Shastina on the side. That's a flanking eruption, so that's a pretty famous volcano that's part of one of the southernmost volcanoes in the Cascade mountain range. But this one extends this is in Northern California. And Mount Kilimanjaro, of course. I asked, can you name this famous volcano? And I just said what it was. But this is Kilimanjaro in Eastern Africa, and pretty famous volcano. Caldera, in fact, and this is the top of Kilimanjaro. And then here's one at Pico Island in the Azores in the Atlantic Ocean. Another pretty good example of of a volcanic peak. And just to show you some of these volcanic peaks that are part of the Cascade mountain range that extends really from Canada all the way down into California. But each of these green dots right here is a volcano that's part of the Cascades. And just to show you a couple of them, Mount Baker, I've circled it here. This one's close to the border with Canada. And then we've got Mount Rainier, which is that really famous one that's on a lot of license plates in Washington, or at least used to be. Mount St Helens, the one that blew its top. I've circled it there. It's a little bit in the southern part of Washington. Mount Adams, another pretty well-known mountain of the Cascades. We've got Newberry Volcano, which is a whole bunch of different volcanic features. And then finally, Mount Shasta and Shastina. You can see Shastina a little bit better, and that's one of the southernmost volcanoes. This one way here at the south is actually Mount Lassen that I mentioned. And this is looking actually from Mount Hood towards Mount Jefferson off in the distance. You can see the whole string of these mountain peaks and the Cascades. Really beautiful places. And just to show you the frequency of eruption, we look at the same map that we looked at a minute ago, but here's how often some of these volcanoes have erupted. And hopefully you can follow those red lines, but look at the number of eruptions that Mount St. Helens has had. And of course, its most recent one was really dramatic back in 1980. But some of these volcanoes haven't really erupted very often, and including Mount Lassen, only a few somewhat recent eruptions. Okay, Caldera. I mentioned a caldera is where a composite volcano collapses on itself. It's pretty dramatic. A really beautiful example of that is Crater Lake in Oregon. This is called Wizard Island here in the middle of Crater Lake, but it would represent a later small eruption that took place within the crater. And of course, the lake came much later. The lake is just something that this cavity filled with water much later. But this is a pretty national park in southern Oregon, and definitely one you should try to see. And here's sort of how a caldera forms. It's there's the volcano sort of exploding, and it kind of collapses on itself, and it forms that caldera, that great big sort of basin. Okay, a couple just for fun. Where is the most dangerous volcano on Earth? Can you imagine where that might be? And you might be surprised when I tell you where the most dangerous volcano, actually any volcano that's erupting that you're standing next to is the most dangerous volcano on Earth. But in general, if you're looking sort of across the whole world, what's the place that has the highest potential for really something catastrophic? And it's in the U.S., the lower 48, and you might have guessed it. Here's the secondary ash zone that might be created by this particular area, the primary ash zone, and the kill zone for this volcanic region that's extremely famous, and that's Yellowstone National Park. And in fact, this red line right here represents the edge of the caldera, the Yellowstone caldera. Yellowstone Lake is down inside that. If you're on a tour of Yellowstone and you're in the bus or you're in your car, make sure you pay attention as you're kind of going up driving, let's say up from the south. If you're coming up from the south, there's generally a sign that tells you when you're crossing over the rim of the caldera. They have that marked. But this is a pretty dangerous place, and here's why it's so dangerous. The magma is so close to the surface at Yellowstone National Park. I'm not saying it's something you need to worry about. I've been there a number of times, and I'm not really very worried. But here's a prediction from a scientist from one of the main universities in Poland, who's saying that he thinks within sometime in the future there's going to be another super eruption of Yellowstone. And here's sort of what it might have looked like when it went off the last time. Okay, so with that, what's the deadliest volcanic eruption that's ever happened in U.S. history? The deadliest volcanic eruption in U.S. history. Well, I've kind of given it away. It was back in 1980, May 18th, 57 people, mostly killed from asphyxia from ash, and of course that was Mount St. Helens. And here's a view of Mount St. Helens with Spirit Lake in the foreground. Spirit Lake was a really beautiful lake before the eruption. It's still a beautiful lake today, but it looks completely different. So this is before the eruption, and this is the top of the volcano blew off, and this is after a period of time went by when the lake sort of came back and sort of returned to its natural state. But look at how much material was removed from Mount St. Helens during that eruption. It's just a catastrophic eruption. And a view from the air, looking down in the crater, and there's not really a lot that's really grown back. I mean, there's not this. You don't see a lot of trees yet. The soil really hasn't had a chance to recover, so it doesn't look very different today from when this photo was taken. Here you see off in the distance in the upper right-hand corner one of the other mountains in the Cascades. They monitor Mount St. Helens all the time because it still has a potential to erupt again. They have GPS receivers to see if anything's moving, so see if the ground is moving. They have these camera systems, remote cameras, that can capture data and send the images back to a lab to see if there's other types of activity or movement. And they're always monitoring these cracks to see what's going on as well. Here's a telemetry station looking at Mount St. Helens after the eruption with cameras, again remotely operated, with radio telemetry to send this stuff to faraway locations so the data can be analyzed. Okay, how about this one? Where was the largest volcanic eruption on Earth in the last 10,000 years? And I bet you don't know where this is. This is pretty obscure. But just for fun, it was an island that's in southern Japan, a submarine caldera that's actually formed by 3 islands. And I've created a diagram here so you can sort of see what's there today. And this is one of those islands that you're looking at right here that was affected by this eruption. And so this is a pretty big eruption 6,300 years ago. All right, a couple other features, volcanic features. I wanted to mention Volcanic Neck is the remnant of a big volcano where not really a lot is left of it, just really the neck or the place where the molten magma came upward. This is a famous volcanic neck called Ship Rock. It's located near the Four Corners region, where the 4 U.S. states come together: Colorado, Utah, Arizona, New Mexico. And I've got a little animation that sort of helps you to visualize. So this was a great big volcano at one time, probably even bigger than the way I've drawn it here. But here's my animation to sort of show you how erosion that kind of kept removing material from this volcano over time, reduced it down to what it looks like today as a volcanic neck. Here's another one. I was traveling in West Africa on this island called Sao Tome a few years back, and I was really curious. My travel companion and I saw this thing and had no idea what it was, and we had some theory that it was volcanic in nature, and so I had to come back. And the first thing I did, of course, was try to do some research to figure out what it was. But it's something called the Pico Cayo Grande volcanic neck on the island of Sao Tome. I'm showing where that is here. Here's Africa, and where that little black square is right there. That's where this island is located. And the actual peak is about where I'm pointing right there in the southern part of the island, but a pretty unusual volcanic peak. A couple other things I mentioned: cinder cones. We won't spend a lot of time with cinder cones, but here's sort of how cinder cone forms. If you look in the upper left-hand example, I'll sort of walk you through. I'm going to build the cinder cone up. You can see it growing here as cinders fall, and these are some cinders here, sort of the size of the cinders that I was mentioning. Hawaii Volcanoes National Park and elsewhere on the Big Island, Hawaii, covered with cinder cones are just everywhere. One famous cinder cone you can go see if you get in your car, if you live in Oklahoma, that is, and you get in your car, you could drive to this cinder cone within a half a day's drive. And this is Capulan Mountain Cinder Cone in New Mexico. It's sort of in northeastern New Mexico. And the visitor center here, this is actually a national monument, U.S. national monument. You can take the road if it's during the day, and you can drive up to the top of the cinder cone, but it's pretty impressive if you want to see a cinder cone. Okay, lava tubes. Lava tubes are passageways that lava travels through. Here we see an example of lava just sort of disappearing down into one of these passageways. Here in the bottom image right here, you see a lava tube that has some hardened material inside it. Some of these lava tubes are pretty good size. This is a lava tube on the Big Island, Hawaii, and the Hawaiian Islands. You want to be kind of careful if you go near these, because sometimes the stuff is pretty crusty and you definitely don't want to break through. This is the lava tube at the Thirstone. This is the Thirstone lava tube on the Big Island. You can actually walk around. There's several miles of passageways, actually, if you want to walk around and experience a lava tube. Lava Beds National Monument also has some interesting lava tubes that you can check out. Kind of interesting. And finally, last thing I want to mention are materials ejected by volcanoes. We'll look quickly at these materials just so you can appreciate what the size. This video shows you volcanic bombs or big chunks of molten lava that fall to the ground. That, in some cases they can be as big as automobiles. I mean, some of them are massive. They're hot. You don't want to get hit by one. They're pretty dangerous. So don't go near a volcano that's erupting with this type of thing. But here's a sort of a typical size, one of the bigger ones. These volcanic bombs that's been ejected by a volcano. Most of what's ejected by volcanoes though is pretty small. A volcanic ash that looks like this. This is a video showing a volcanic ash, and this volcanic ash, if you were to look at it under a microscope, it has those same features that you'd find associated with other extrusive igneous material, lots of air holes, and sometimes that ash is powdery looking. Sometimes it's kind of almost looks like flour. And here's volcanic ash on the island of Iceland. And just to give you a feel for how much volcanic ash has been associated with some types of volcanoes or volcanic eruptions that you may be familiar with, from the 1980 Mount St. Helens eruption, there was the estimated amount of volcanic ash was about 1 cubic kilometer of material, which is a lot if you think about it. But compare that to Mount Katmai in the Hawaiian Islands when that erupted in 1912, about 12 cubic kilometers of material ejected. And then Krakatoa, I can't even show something big enough to represent how much ash came out of that one, but over 18 cubic kilometers of material was introduced into the atmosphere in 1883. And just so you can see, this is Mount St. Helens and some of the ash areas affected by ash by Mount St. Helens. And Mount St. Helens shown right here in the red dot, and some of those areas of ash shown in the gray.